Physics students, good afternoon. Mr. Fewy here. In this video today, what we're going to be doing is looking at the graphical kinematics practice problem set that we went over in class. But here, what we're going to be doing is solving through each part of the problem and talking through how we can analyze both position versus time and velocity versus time graphs. You can access this document with a key on Canvas in our Unit 2 page, but here we're going to be walking through each part of the problem. I am going to assume that you have the document at your disposal, and so if you're having a little bit of trouble seeing some of the exact values, make sure that you reference Canvas for the document itself. So the very first graph that we were given here in our graphical kinematics practice is a graph of position versus time. So if we come down here, question number 1 says, what are the positions of the object at time 3, 6, and 10 seconds? Since our graph tells us about the position, all we need to do here is directly read our points. So I'll go to a time of 3 seconds, right between 2 and 4. Come up to my graph. I'm at a position of approximately 2 meters. So at 3 seconds, my position is 2 meters. We'll next look at 6 seconds. So I'll come over here to my point at 6 seconds. Trace up on my graph. Looks like I'm right near about a position of 4 meters. And then lastly, at a time of 10 seconds, so I'll come to a time of 10 seconds, looks like I'm at a position of 0 meters. That's where my line is hitting. So at 10 seconds, I'm at a position of 0 meters. So because our graph is a position versus time graph, we can just read our points directly to tell us about the position. Next, question 2 says, what is the velocity of the object during 3 different time intervals? 1, 2, 3 seconds. 4 to 5 seconds, and 8 to 10 seconds. So what I'll do here is we want to find the velocity, which that should trigger in our minds. We can't find that directly, but because we have a position versus time graph, we'll need to find the slope. So first we'll look at 1 second to 3 seconds. So what we'll do here is I'll come up to my points. At a time of 1 second, I'm at a position of 2 meters, and at 3 seconds, I'm at a position of 2 meters. So I'll have here a point. 1 second, I'm at a position of 2 meters, and at 3 seconds, I'm at a position of 2 meters. So here I'll just find the slope between those points. So y2 minus y1, so 2 meters minus 2 meters over x2 minus x1, 3 seconds minus 1 second. This is 0 meters over 2 seconds. 0 over 2 gives us 0 meters per second. So in this scenario, right, our velocity would be 0. And we can also tell that just by looking at our graph. We have a flat line here, which means our position doesn't change, which by definition means we have no velocity. So next we'll look at a time of 4 seconds to 5 seconds. So, sorry about that. 4 seconds to 5 seconds. I'll erase a few of these points here. 4 to 5 is going to be from 4 is about here up to 5. So my positions are 3 meters up to 6 meters. So we'll come back down. We'll go at a time of 4 seconds. We're at a position of 3 meters. Just double check that point. And then at 5 seconds, we're at a position of 6 meters. So the slope between those points, y2 minus y1, 6 meters minus 3 meters, over x2 minus x1, 5 seconds minus 4 seconds. So 6 minus 3 gives me 3 meters. 5 seconds minus 4 seconds gives me 1 second. So 3 over 1 gives me 3 meters per second. Just the slope between those 2 points. Now if I wanted to know the velocity at 4.5 seconds, or 4.8 seconds, or 4.1 seconds, those would all be 3 meters per second because I have a constant slope between 4 seconds and 5 seconds. Okay? Now our last time interval is a time of 8 to 10 seconds. So 8 down here to 10. You'll notice this is one of the portions on our graph where our slope is negative. So we should have a negative velocity during that region on our graph. So at 8 seconds, we'll write down our point. Scroll down just a little bit. 8 seconds, we're at a position of 2 meters. And at 10 seconds, we're at a position of 0 meters. So the slope between those points, y2, 0, minus y1, 2. So 0 meters minus 2 meters, divided by x2 minus x1, 10 seconds minus 8 seconds, So we have 0 minus 2 gives me negative 2 meters. 10 minus 8 gives me 2 seconds. So 2 over negative 2 gives me negative 1 meters per second, which is going to tell us our velocity here is negative, meaning we have a negative slope. We're traveling there in the negative direction. So here we were able to find the velocity during our 3 different time intervals using slope. So we'll come now to the third and fourth questions. Question 3 here says, when if ever is the object not moving? Well, by definition, the object is not moving whenever our velocity is equal to 0 meters per second, which for a position graph means we have a flat line. Our position is not changing. So if I come back to my graph, there are, it looks like, 2 regions where that is happening. I'll erase these in here. Where is my position not changing? Where is my slope 0? Well, it looks like from 1 second to 3 seconds, right in here. And then from 7 seconds to 8 seconds, this region right in here. Those are points where our velocity is 0 because we have 0 slope on our graph. So we would say, where velocity is 0 meters per second, which occurs from a time of 1 second to 3 seconds and 7 seconds to 8 seconds. Because our velocity is 0, we could also say our slope is 0. We could also say our position remains constant, doesn't change. Any of those would be accurate descriptions of why our object is not moving. And then lastly here, question 4 says, when if ever does the object turn around? Well, when our object turns around, that means our velocity changes sign. We go from having a positive velocity in one direction to having a negative velocity in a separate direction. So where does our velocity change sign? Well, because we have a position graph, remember, what we do is very, very dependent on the graph we have. Because we have a position graph, if the velocity changes sign, that means we're looking for where does the slope change sign, because this is a position graph. So I'll come back here, I'll look at my graph. Well, this first region here, erase this part. This first region here, I have a positive slope. I'm increasing. No slope, so positive to 0. That doesn't mean a change of sign. Positive slope, positive slope. But right here, at a time of 5 seconds, now my slope becomes negative. So at a time of 5 seconds, I go from a positive slope to a negative slope, which means my velocity changes sign, and I have a change in direction. I am turning around. So we would say at a time of 5 seconds, because our velocity changes sign, or our slope changes sign. Okay? Either of those would be accurate descriptions as to why our object turns around. Okay? Hopefully this gets you started on some of the questions we might be interested in answering with a position versus time graph. Okay? In our next video, we'll look at the velocity versus time graph. Good luck.